Here we have a question from JEE Advanced 2026 from paper 2 online. In this question it's given that there is a nuclear reactor that starts producing a radioactive nuclide X from time t equal to 0. So इस क्वेश्चन में हम देखो कि हमारे पास एक न्यूक्लियर रिएक्टर है जिसका इमेज मैंने बना दिया है और ये एक रेडियोएक्टिव न्यूक्लाइड X को प्रोड्यूस कर रहा है टाइम t इक्वल टू 0 पे एट कांस्टेंट रेट ऑफ अल्फा पर सेकेंड. सो टाइम इक्वल टू 0 कांस्टेंट रेट ऑफ अल्फा पर सेकेंड पे ये न्यूक्लियर रिएक्टर इसको प्रोड्यूस कर रहा है न्यूक्लाइड को. ईच डीके ऑफ X प्रोड्यूसेस एनर्जी E नॉट व्हिच इज यूटिलाइज्ड टू हीट ए लिक्विड ऑफ मास m. सो यहाँ पे अगर एक न्यूक्लियर रिएक्टर है हमारे पास, सो यहाँ पे डिफरेंट ऐसे न्यूक्लियाइड प्रोड्यूस हो रहा है और एक न्यूक्लियाइड से जो एनर्जी हमें मिलता है वो है हमारे पास E नॉट. सो पर न्यूक्लियाइड हमें E नॉट एनर्जी यहाँ पे मिल रहा है विच इज़ यूटिलाइज टू हीट ए लिक्विड. यहाँ पे एक लिक्विड है और ये जो न्यूक्लियर एनर्जी हमें मिल रहा है वो इस लिक्विड को हीट करने के लिए इस्तेमाल हो रहा है. अब मास m एंड स्पेसिफिक हीट S, इस लिक्विड का हमें मास m गिवन है और स्पेसिफिक हीट कैपेसिटी इसका हमें S गिवन है. Assuming no heat loss from liquid and taking lambda as the decay constant of X, the rate of increase in temperature of liquid is. So in the question we have to find the rate of increase in temperature of the liquid. So for this we can solve it in the following way, that you can see in the question it's given that at t equal to 0 you can see that nuclear reactor starts producing radioactive nuclide from nuclide X from t equal to 0. So at X equal to 0 there are no nucleides or 0 nucleides. So imagine a time t, at time t equal to any time t, let X equal to n. It means the number of nucleides generated be n, and at t equal to, let t equal to t plus dt, that is a small time after the time interval t, it becomes X equal to n plus dn, that is a small number of nucleide change has been there. It may be either produced or it may be either decayed. I mean that dn is total number of nucleides that is produced minus total number of nuclei that gets decayed. And in the question it's given that at a constant rate of alpha per second starts producing radioactive nuclei. It means alpha per second. It means Tn will be equal to produce, that is how many nucleides are producing. If alpha nucleides are producing per second, then alpha dt nuclei will produce in dt seconds, and minus it's given that the lambda is the decay constant. So according to the radioactivity equation we can write minus decay, the value of decay is lambda into n, lambda n into dt, because we know that dn by dt is equal to minus lambda n, and it's specifically for decay equation. And after this what we can do is just integrate it. Now you can do like this, that यहाँ पे जो dn है इसके नीचे हम माइनस, एक सेकेंड, ये जो इक्वेशन हमें मिल गया dn इक्वल टू अल्फा dt माइनस लैम्डा n dt. सो इसको हम ऐसे लिख सकते हैं, dt को हम कॉमन ले लेंगे, dn इज इक्वल टू अल्फा माइनस लैम्डा n dt implies dn by alpha minus lambda n is equal to dt, एंड यहाँ से हम लिख सकते हैं कि इंटीग्रल डी एन अल्फा माइनस lambda n is equal to integral dt from time t is equal to 0 to t is equal to t, and the value of here in dn is from 0 to n, because you can see that initially it was 0 and finally it reached up to n. So after solving the integration, what we get is dn divided by alpha minus lambda n. So if we solve this differentiation, then it becomes 1 by minus lambda, because here is minus lambda multiplied with n, and ln alpha minus lambda n. And alpha minus lambda n, and here you can see that while we are integrating it from 0 to n, so first of all it will be multiplied by n. I mean, first of all we will take n is equal to n, and then we will take n is equal to 0, and if we take n is equal to 0, then you have to write minus ln alpha equal to t, as we integrate t from 0 to t. So from here we can write alpha minus lambda n by alpha is equal to e to the power minus lambda into t, and from here you can write lambda n is equal to alpha 1 minus e to the power minus lambda t. So finally we have got the value of lambda n, and see, we needed the value of lambda n for dn by dt. And now see, we are given here in the question that mass and specific heat capacity of the liquid are m and s, and we have to find the increase in temperature of the liquid, and to find it we have to use the equation. You know the equation of that contains the specific heat capacity, that is dq is equal to m s dt, and here dq will be, see, dq will be E naught into total number of nuclides that is produced minus that is total number E naught multiplied by total number of nuclides that is decayed, and the total number of nuclides that is decayed is lambda n dt. E naught into lambda n dt is equal to ms dt, because you know that the energy that we receive is from the decaying of nucleus, because see that each decay of x produces E naught, so we have to find that how many decay are there, and each decay produces E naught, so total decay multiplied by E naught is equal to ms dt, and if we solve it, then it becomes E naught into lambda n is alpha 1 minus e to the power minus lambda t, dt is equal to ms dt, and here we have to find the rate of increase in temperature, that is dt by dt, that is change in temperature by change in time, that is the rate of change of temperature, is equal to E naught alpha 1 minus e to the power minus lambda t divided by ms. So here you can see that the option number A becomes the correct option. Alpha E naught divided by ms 1 minus e to the power minus lambda t. So clearly the option number A here becomes the correct option.